So you'll want to note that you have to be very careful when you are rounding off your decimals, because 2.67 and 2.75 might both look like they should be around 2.7, but you're going to find that they actually end up with very, very different numbers. So make sure that when you're going through your calculations, you don't round off until the end. Okay, so we're going to go through this one. I'm going to show you that it's kind of a tricky one. If you had rounded off in the first set of these calculations, you'd end up with the wrong number. So we're going to go do it right. So I've got silicone is my first ingredient, and it tells me that I've got 39.0%. Let's just back this up a little bit. Silicone gives me 39 grams because I'm assuming that I have 100 grams. Now I'm going to multiply that by grams on the bottom, 28.1 grams with 1 mole over there, because it's 28.1 grams per mole on the periodic table. Now that is going to give me 1.39 moles as my answer. I move on to the oxygen, and the oxygen tells me I have 61 grams because I have 61% of 100, and then I'm just going to do the same thing here with 16 grams per mole. When I go 61 divided by 16, this is where it gets tricky because it gives me 3.81. Do not round. Just leave it the way it is. Okay, and I'm not going to round this off either, because when I divide, I'm going to divide by the smallest number, and I'm going to get 1 and 2.74. Now here's where you can round a little bit, because I can go, okay, well 2.74 is close to 2.75, and that's one of those useful decimals that I can use, because 0.75 is 3/4, which means for this next column I'm going to multiply by 4, because that is approximately 3/4. Multiply by the bottom number, and that's going to get me 4. And 2.75 times 4 gets me 11. So now I know that I have 4 silicons for every 11 oxygens. So I'm going to go Si4O11. And there is my empirical formula for this situation.